Hello dear learners, today we are going to talk about the trick to remember the classification of general anesthetic from pharmaceutical chemistry. In our earlier video, we have seen the general information on what is general anesthesia, what are the properties of the how the anesthesia should be produced. Then we have seen the characteristics of anesthesia. Then we have seen the phases of anesthesia, that what are the 4 stages and the description of the phases. In this we are going to talk about general anesthetics. Earlier part was covering general anesthesia. So general anesthetics, whatever are there, these are the drugs which are producing the state called as general anesthesia. So general anesthetics, these are the drugs or agents which cause CNS depression. So as you very well know, in the general anesthesia definition we have seen it is the state of reversible CNS depression. In that CNS depression occurs, but it is of reversible nature, which will produce loss of consciousness along with the analgesia. So drugs will also remain same. These are the drugs or the agents which cause CNS depression, producing reversible loss of consciousness. That means they cause the CNS depression, but they produce along with that consciousness is lost, but it is of reversible nature. That means it can be regained once the effect of the agent wears off or the effect of the drug wears off. And insensibility to pain, that is analgesia. That means the patient will not feel the pain. So the definition is these are the drugs or the agents which cause CNS depression, producing reversible loss of consciousness and insensitivity to pain. Now other definition which you can write it reframing or restructuring the words is these are the CNS depressant drugs which bring about, means CNS depression they have taken it earlier, and they which bring about loss of all modalities of sensation. Now here analgesia is first, brings about loss of all modalities of sensation. That means analgesia in short they want to say, with reversible loss of consciousness. So it is same, only analgesia they have taken first and then reversible loss of consciousness is later on. And these are the drugs which cause CNS depression. Instead of that they have written these are the CNS depressant drugs. So any of these is appropriate, whichever you feel comfortable you can write that in exam along with the example halothane, chloroform, ether, etc. These are the examples of general anesthetic which we are going to discuss in detail in the classification and drugs part of general anesthetics. Now ideal properties of general anesthetics are, coming towards the properties of general anesthetics. Now general anesthetics के class के जो drugs है, what all properties they should have? First of all, these are the general properties which every anesthetic should have. It should be inert, it should be potent, non-toxic, non-flammable, non-irritating to the mucous membrane. These are the general properties. Like it should be inert, it should not react once administered. It should be potent, that is in a small dose it should produce the anesthesia. Then non-toxic, toxicity should not occur once it is administered. It should be non-flammable. So for building up the non-flammable features we can do the structural modifications, such as in halothane, like they have substituted halogen, that to higher halogens like fluorine in case of halothane. So they become non-flammable. Then non-irritating to the mucous membrane, they should not cause any irritation. And the characteristic properties are it should produce rapid and smooth anesthesia, faster as well as smooth anesthesia. Recovery should also be easily possible. Then it should be compatible with other general anesthetics. Whatever are the other members of general anesthetics, this general anesthetic drug whichever is administered, they should be compatible with the other agents. Now coming towards the classification of general anesthetics, we need to remember this trick only for the non-barbiturate class, because other examples, if you will see, these are as simple as, means you can easily remember. So first of all, to start with the classification is having two major classes. First is inhalation, second is intravenous. So as you can see the terminologies, you can easily make out the general anesthetics are classified based on their route of administration. First is inhalation route and another is intravenous route. So inhalation are also known as volatile agents and intravenous are also known as chemical general anesthetics. So in exam, if only the question is asked, classify general anesthetics, give the classification of general anesthetics based on the chemical classification, so only this class you are supposed to write, this 4 sub classification. And if the question is asked like classify general anesthetics based on the route of administration, so both the classes you are supposed to write down. Now inhalation route, they are given by inhalation, which are volatile in nature, are further subdivided into 2 classes, which are very simple. Regular examples are there, you can easily remember, no need of trick and all. So liquids and gases. As the name suggests, liquids, they are liquid in nature. As the name suggests, gases, they are in gaseous form. So liquids examples are ether, chloroform, halothane. Now these are ether, chloroform, you very well know. In movies also you might have seen that they used to put some liquid on the handkerchief, and then they used to keep it in front of the nose of whatever the person they want to kidnap or whatever. So that chloroform is used to anesthetize that person, that too which can be recoverable or reversible. So chloroform, you very well, all of you might be knowing chloroform. Then ether also you have seen in the lab, it's a liquid, transparent liquid. So ether, there are 2 ethers, diethyl ether, vinyl ether. Then chloroform is there, halothane, which is the very very important drug from the general anesthetics, which we have discussed in the repeatedly asked questions. And along with these 3 members which comes under inhalation class, that too liquid subclass, other examples are N-fluorine, split the word, N-fluorine. Now this fluorine is common, only the prefix will change. Suffix fluorine is common. N-fluorine, isoflurane, you are supposed to talk along with me. N-fluorine, isoflurane, desflurane, sevoflurane, methoxyflurane. So if you will see, the fluorane suffix is common to all the series members, and the N-fluorane, iso, des, sevo, methoxy. So for remembering these other members of the liquid series, we have one trick, that N, de, seva, me. So N is for N-fluorane, de is for desflurane, seva is for sevoflurane, then me is for methoxyflurane. N, de, seva, me. N-fluorane, de for desflurane, seva for sevoflurane, me for methoxyflurane, and remaining is isoflurane. So this you will easily automatically remember when you will remember all these examples. So the complete inhalation liquid class includes, first is, again you are supposed to repeat it along with me, ether, diethyl ether, vinyl ether, chloroform, then halothane, then N-fluorane, isoflurane, desflurane, sevoflurane, methoxyflurane. You are supposed to split the words N-fluorane, isoflurane, desflurane, sevoflurane, methoxyflurane, and that's all. N, de, seva, me. Then gases. If you will see, the other subclass from inhalation class of general anesthetics based on the route of administration, the other class is gases. So you very well know that gaseous form, this cyclopropane. Now the structure is very simple and it is repeatedly asked in the exam. Cyclopropane. Cyclopropane, as the word suggests, cyclo, it is cyclic form, propane, that means 3 carbon. So it is triangle. Bingo, mad angles. Triangle, simply you are supposed to draw the triangle. CH2, 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 and you are supposed to combine it in a cycle form. Then second is nitrous oxide, which is N2O, and third is xenon. So these examples are also quite easy to remember. Then coming towards the intravenous route or chemical general anesthetic, which is separately asked in the exam as a separate question that classify the general anesthetics or give the chemical classification of general anesthetics. So as inhalation we are subdivided into 2 classes. The chemical general anesthetics, that is intravenous route administration general anesthetics, are further subdivided into 4 major classes. The classes are first, and you are very much familiar with this name since we are studying all the CNS acting drugs from long time. We have studied sedative hypnotics, we have studied tranquilizers. Now we are on this general anesthetics. So these you are very well aware about these 2 classes. So first is benzodiazepine. Benzodiazepine, you have heard this word. So diazepine means 2-aza. So it is a 7-membered ring, diazepine ring, and benzene ring. So benzene and diazepine fusion it is there. The examples include from the general anesthetic part of point, that is diazepam, lorazepam, and midazolam. Diazepam, lorazepam, midazolam. Then from barbiturates, the class, this also you have heard, barbiturates. So barbituric acid is synthesized from the urea and malic acid. So this barbiturates, the examples we have seen, thiopentone and methohexitone. So the trick is barbithime, barbiturates. Barbi is for barbiturates, thime, thiopentone is, thi is for thiopentone, me is for methohexitone. So barbithime, barbiturates. Examples are thiopentone sodium, methohexitone sodium. Thiopentone can be also written as or known as thiopental, and methohexitone can also be written as methohexital because of the ketoenol tautomerism, which we have discussed in brief in the sedative hypnotic class. Then benzodiazepine barbiturates, you are very much familiar with it. Then the next class is non-barbiturates. Now non-barbiturate class is again further subdivided into 6 classes. So all these 6 classes, to remember the trick to remember these classes is hi, say, hello, hello, chalo idhar, stay all day. Hi, say, hello, hello, chalo idhar, stay all day. So this trick, how you can correlate with the classes and their examples, I will tell you. Now before correlating, I would like to focus on this part, the names hydrocarbons and halogenated hydrocarbons. Now in case of liquids we have seen chloroform. So what you can see in the formula of chloroform, it is CHCl3. That means it contains carbon, hydrogen and halogen. But what you can see in case of cyclopropane structure, it only contains carbon and hydrogen. So the compounds which contains only carbon and hydrogen are called as what? Hydrocarbons. And the compounds which contains carbon, hydrogen along with halogen, they are also called as, halogenated hydrocarbons. That means they are hydrocarbons only, but they are substituted with one or the other halogen. So they are called as halogenated hydrocarbons. So hydrocarbons are carbon and hydrogen containing compounds, and halogenated hydrocarbons are carbon, hydrogen and halogen containing compounds. Hydrocarbons, halogenated hydrocarbons, these are the 2 simple classes from non-barbiturates which have further subclassification as 6 classes. Then coming towards the third class, which is again from liquids only. the from inhalation part. So the third class is ether. Now ether we have seen here, diethyl ether and vinyl ether. So the class name is ether and it includes diethyl ether, vinyl ether. Again the formula of diethyl ether is again very simple and it is asked in the exam. So cyclopropane, then halothane and ether. These diethyl ether, these three structures are asked in the exam. So now ether, diethyl ether, it is also again very simple. ROR is the general formula for ethers. Now when the first R is substituted with ethyl and the another R also is substituted with ethyl, it is diethyl ether. Right hand side R is also ethyl and left hand side R is also ethyl, and in the center there will be O. So ROR, that is ether, and when both the R's are substituted with ethyl, it is diethyl ether and then vinyl ether. Then next class is, now these are the three classes, other three classes. These three classes are again very much easy to remember, and then other three classes are eugenol derivatives, then inducing agents, then steroids. Now eugenol derivative, if you will see eugenol derivative example is propanidid. If you will split the words, propanidid. Eugenol derivative is propanidid. Now UG means undergraduation. So it is not as simple as that of diploma. Undergraduation is always difficult. So eugenol derivative में UG में problems है, मतलब बहुत डिफिकल्ट है, प्रॉब्लम्स है. पण आई डिड, इन मराठी यू कॉल पण मी केले, सो पण आई डिड. सो यूजिनॉल डेरिवेटिव यूजी में प्रॉब्लम्स है, पण आई डिड. सो यूजिनॉल डेरिवेटिव प्रोपैनिडिड, यूजी में प्रॉब्लम्स है, पण आई डिड. सो यूजिनॉल डेरिवेटिव इज प्रोपैनिडिड. Then hydrocarbons, if you will see, just now I have given you the example cyclopropanes and ethylene. So cyclopropane, ethylene are the examples of from the hydrocarbon class. Then halogenated hydrocarbon, we have seen the description that it is halogen along with carbon and hydrogen. So the compounds are chloroform, halothane. So it is chloroform, halothane and ethylene chloride. Ether, diethyl ether and vinyl ether. Then inducing agents are propofol, etomidate and droperidol. The examples are propofol, etomidate and droperidol. And from steroids, the example is althecin. Now this high say. Now hydrocarbons, high stands for hydrocarbon, C stands for cyclopropane, E stands for ethylene. So hydrocarbons contains cyclopropane and ethylene. So it is high say. Now coming towards the other, halo, chalo. Now here halo, halogenated. First halo stands for halogenated. Second halo stands for halothane. Halo. Halogenated hydrocarbons includes halothane. And chalo is for chloro, that is chloroform, and the other example is ethylene chloride. Now either, stay all day. Now either is for ether. Two examples you very well know, diethyl ether and vinyl ether. Stay all day. Now stay all day is steroids class, that is steroids. Stay is for steroids, all day, that is althecin. Steroids example is althecin. So it is high say, halo, chalo, either, stay all day. So all these classes. Eugenol separately I have told you the trick. UG में problem, पण I did. Eugenol derivative propanidid. And then inducing agents are propofol, etomidate and droperidol. And the remaining class, fourth class, which is others, which is also known as phencyclidine derivative or dissociative anesthesia. The example of this is ketamine, which can also be included in the inducing agent. The example is ketamine. So with this we finish with the classification of general anesthetics. Again I will repeat the questions. The questions asked are: classify general anesthetics, or chemical classification of general anesthetics is asked. Then you are supposed to mention only these 4 subclasses and non-barbiturate subclasses. But when the question is asked like classify general anesthetics based on the route of administration, then this complete classification you are supposed to write. First is by inhalation route and other is by intravenous route. So both the routes you are supposed to mention, and the subclassification of both the routes you are supposed to mention. Now in detail, halothane is important. So halothane we are going to discuss in the next part, which is a very important general anesthetics. With this we finish with the trick to remember the classification of general anesthetic. You are supposed to revise it properly. You are supposed to go through the repeatedly asked questions, where you will find the type of questions which are asked till now and which are very important from the exam point of view. Thank you.